Tech Study channel. So in the previous class, I have explained about first important question and its answer of DBMS subject. So in this class, I will explain second important question and its answer. So the second important question is file versus DBMS, or we can say difference between file system and DBMS, or characteristics of file system and DBMS. Okay, DBMS means database management system. Okay, so first we will see. So here, file system. File system is a software used to manage and organize lines. um File is a software used to manage and organize files in a storage medium within a computer. Storage medium means hard disk, SSD, etc. like that. And it is used to manage and organize files, okay, in a storage medium within a computer. So what is file here? File. So file is a file in a file system is named a collection of related data stored as a single unit on a computer. Named a collection of related data stored as a single unit on a computer. Okay. So and then related data means we already know, means how the different pieces of data is connected to each other, logically connected to each other. So like customer name and their purchase history and their address, etc. Okay. And so related data, collection of related data stored as a single unit on a computer. Okay. And single unit means the computer treats the entire collection of data as one individual object with its own distinct identity. Okay. It considered as an The collection of data is considered as an individual object within its own distinct identity. So, means in practice, single unit means in practice one name, one action, one location, no splitting. Okay, one name is the system gives the unit one unique file name, example photo.jpg, and one action means moving, copying, or deleting. It affects all the data inside it at once. Okay. And one location, the computer tracks it as a single entry in its master storage index. Okay. So in the master storage index, it treats like a single entry. Okay, a file treats like a single entry, and no splitting. We can't open or move just a piece of that specific file by itself. Okay, we can't divide it into pieces. Okay, and then every file has a name, usually and usually an extension. Okay, like .gpg, .mp3, .mp4, .txt, .xe, and that tells the system what kind of data is inside, like image for gpg, audio for mp3, and video for mp4 extension, and text for txt, and program for exe, and etc., and many more there, like CSV and etc. And files are kept in permanent secondary storage. Okay, such as a HD means hard disk and SSD, and so they remain available even after we turn off computer. Okay. And files are grouped into directories, means to keep them organized. Okay. Means directories means collection of files is called directories. Okay. To keep them organized, for example, for different projects, we can use different directories which contains number of files. Each directory contains number of files related to that project. Okay. And then metadata. Metadata is a data about data. Okay. So the system tracks hidden details about the file, such as its size, when it was created, and who can has permission to open it. Okay. Then operation used to perform on file: create, read, or open, write or edit, delete. So create, make a new empty file. Okay. It creates a new empty file and view the information inside. Okay. Change or add new information. Okay. And remove the file and free up storage space. By using this operation we can perform these operations. Okay. And then we will see what is database management system. Okay. What is database management system? We have already seen in the previous class, that is a group of program that manipulates, means store, manage and facilitate access the database and provide interface between database and user of the database. Okay. So data here, database means is the organized collection of related data that can easily accessed and administered and managed by using computer based DBMS. Okay. So we will see what is data. It we have understand what is database. It is an organized collection of related data. Okay. So what is data? So data is a collection of raw unorganized facts and figures that can be processed to produce meaningful information. Okay. So raw unorganized data, collection of raw unorganized facts and figures, means standalone unlinked contextual data. Okay. Standalone means which has their own meaning by itself. Okay. So example, uncontextual means, contextualizing means we know according to any topic organizing the text data. So uncontextual means the data is not organized according to according to a particular topic. It is chosen from or randomly selected from any topic. Okay. And now examples: numbers, text, etc. Numbers like 90, 85, 95, 12, undistributed list. And text: apple, red, Hyderabad. Okay. Any text we can, any word we can say here. And then processed data, so a collection of raw unorganized fact and figures that can be processed. Okay. To produce meaningful information. So these raw data is processed, how means linking, contextualizing, analyzing data, so that data makes sense and has meaning. It becomes information. Example: so processing a student's unorganized monthly test scores results in calculated averages, percentages, and ranking and pass or fail grades. So here the raw data is unorganized monthly test scores, and here the processed data is average, percentage, and ranking and pass or fail grades. Okay, and another example is scanning a product barcode processes unorganized item numbers and prices into an itemized customer receipt with tag and grand totals. So here the unprocessed data is number of items and price and their prices. So they are itemized customer receipt. They are processed into itemized customer receipt with tax and grants. Tax and grants are processed data. Okay. Then what is related data? How pieces of data connect to one another logically within the system. Examples: customer name, their purchase history, uh, shipping addresses, etc. So here the pieces of data represents customer name, purchase history, and shipping address. So they are logically connected to each other within a system. And then how the processed data and related data are related to each other. So processed data, what is the relationship between processed data and a related data? So processed data helps to find a relation between different types of data. So we can find the relation between different types of data using processed data. Okay, and then and then second point is our redundant data can be present in file system, and in DBMS the redundant data can't be present. Why? Because redundant data means what? So data redundancy. So here identical data identical data or duplicate files are stored in multiple physical locations, so in a system. So those are called redundant data. Okay, in a file system, this is the definition of data redundancy. In the DBMS it will be different. Okay, and in file system it consumes unnecessary storage and creates confusion recording which version is the most current. Okay, so we will confuse which version of file, which version is most current. Okay, and unnecessary storage it will consume. So and the examples are, for file system, data redundancy examples are saving the same report in different project folders so it is easier to access. So and the next is storing the same music or image file in various locations in a download and a picture library, like different, can say uh, apps in different okay locations. We are saving same music and image files. Okay, and then having multiple means, example, 50 employees save the same 1 MB presentation in separate folders, requires 50 MB of storage. So 50 employees are storing 1 MB presentation, same 1 MB presentation in separate folders. So it requires the 50 MB of storage. And crash dumps repeats data already stored within the main application directory if data present in both Means in crash dumps also, in application also, in app also. If we have data in both crash dumps and in application, if the data is present, then data then it the crash dumps repeats the data, okay, which leads to storage wastage, okay. And if data present in only crash dumps, okay, means the data is unnecessary by application directory, then it is memory wastage, okay. So in both cases means if crash drums and applications both have the same data, okay, same data, so it the crash dumps is repeating the data, okay, it leads to storage wastage. And in case if data is present only in the crash drums, means the data is unnecessary by the application directory, and it is also the memory wastage. In both cases, the repetition of data and unnecessary data are creating the memory wastage, okay. So these are the some examples of redundant data in the file system. And in DBMS, the definition is unnecessary repetition of data across multiple records or tables. Unnecessary repetition of data Unnecessary repetition of data across multiple records or tables, okay. We already know in DBMS the data is stored in a tables format. So we are seeing that unnecessary repetition of data across multiple records or tables. And examples are customer contact information is in every order. So in some designated orders table, storing the customer's full name, phone number and address alongside they place every single order they place. So if one customer makes 50 orders, their address is repeated 50 times. So is repeated 50 times. Means the data is repeated, the address data is repeated multiple times. So this is a redundancy in the DBMS. So order table contains, it always contains in each order they place, the customer place, the address is same, so the repetition of the address will occur, okay. And then second example, storing department name and department head, means HOD, head of the department, in every student's record. So in school and colleges we have a student's record which contains department name and plus HOD name, okay. So if the department name is CSC and if the department head is XYZ name, so the department head and department name will not change. If a student is studying, if the students are studying B.tech, then uh, till the 4 years they completed the, or for each year the department the department name will be same for 4 years, and the HOD will change uh, according to the academic year. And so the same name or same department HOD name is repeating for every single student. Okay, so that's why here the redundancy occurs. And CRM, customer relationship management, connect all customer data at one place. Okay, so this is the function of this CRM. Okay, customer relationship management, connect all customers data at one place, has a customer table, and the building system has a separate client table, both containing the same names and emails, create redundancy across organization. So it has CRM. This management has a customer table and a billing system, which has a separate client tables, both containing the same names and emails. Okay, emails of the customers. So here the client table is redundant table. Okay, because it is repeated in both table, customer table and billing system. So creates redundancy across organization, and hence and then hope you understand the what is redundancy and examples of it. And then the next point is third point is it does not provide backup and recovery if data is lost in the file system. Okay, and in DBMS it provides backup and recovery if data is lost. So we will see what is backup. Okay, how long the data survive is the backup. So file system manages where data lives. Okay, backups means how long the data survive, and my file system means manages where data lives. Okay, and then examples of file system are where we can't back up the data or if first is if a drive fails, files are accidentally deleted. Okay, and if I accidentally delete an important presentation file and empty my computer's recycle bin, the file system immediately marks that the storage space as free to be overwritten by a new data. So the original data that was deleted by me is not backup. Okay, can't be recovered. Okay, and third example is if HD means hard disk physically crashes, read write or head damaged. If read and write head damaged, a file system requires functioning hardware to read data. If the disk is dead, the file system goes down with it, and all our data is inaccessible. Okay, and then for this, a file system executes the malicious commands exactly as it should. So, saving the newly encrypted versions of our files over the old ones. So, the system can't tell if a file is being saved by me or you or encrypted by a hacker. Okay. So, file system is executing the malicious commands exactly as it should. So the file system can't tell if a file is being saved by me or encrypted by a hacker. Okay, so and the original in this case, and the original which which I have saved is lost, can't be backup. The encrypted files are there. So in this case, backup is not possible. The file system, that's why the backup is not possible. And if I open a document, make changes, and accidentally click save instead of save as permanently. So I opened a document, okay, make changes, and accidentally click save instead of save as. So what is the difference between save and save as? It saves the already existing file, okay. Means uh, you have created a file with which has a name file1, and you opened it again and you are making changes. So, and after changes you have clicked the save button. So the changes are saved in the pre-existing file name only, file1 name, okay. If I clicked to the save as button, then it creates a new file with the changes which I am making now at present to the file 1, and ask for a new file name, okay. Then I can give f2 a file 2 name, like that, okay. So if I open a document, make changes, and accidentally click save instead of save as, permanently overwriting the original document. So it permanently overwrites the original document, which is file 1. And a file system only keeps track of the current state of a file, okay. Once data is overwritten, the old data is physically replaced on the disk, okay. And then and in the DBMS, we will see some examples in DBMS. If a system crashes, the DBMS restores data to a consistent state, means which is not a temporary state, okay. And then first example is DBMS is connected to hardwired level mirroring. Ensures that if a hard drive fails, an exact duplicate takes over instantly, so the data can't be lost, okay, and it can be recoverable. And the DBMS periodically flushes all modified data from memory to storage and records a checkpoint, okay. It modifies the data from memory to storage, okay, and records a checkpoint. So in Microsoft SQL Server, database checkpoints establish a non-good point, minimizing the time needed to recover the database after an unexpected shutdown. So these checkpoints are used to recover the data, okay. And then scheduled physical entire database or logical copies. Scheduled physical means entire database, or logical copies means log scheduled physical means entire database, or logical means tables or schemas, copies taken daily or weekly, okay. For example, using Oracle Database Recovery Manager to perform incremental backups of a database. So this manager data Oracle Data Recovery Manager so responsible for backups of a database. So database is daily, the entire database is copying daily or weekly. So so if one makes a change in the database, okay. So so other wants that other wants the original data, not the changed data which is created by me. So I can backup, okay, using this copies taken daily, okay. And then we will have a, it provides it okay, this is covered. And there is no efficient query processing in the file system. There is efficient query processing in the DBMS. So what is query processing means? In file system or database is the translation of high level human readable request into low level machine executable instructions, okay. Request to instruction, it is converting, okay. It systematically interprets, optimizes, and executes a request to efficiently retrieve or manipulate stored data, okay. Ultimately it is executing the request, okay. Effectively, efficiently retrieve or to efficiently retrieve or manipulate stored data or stored data. Stored, so the stored data can be retrieved and manipulate efficiently, okay. And then so so what is query processing and in the file system, and why it is not efficient in the file system, we will see through these examples we can understand. And in DBMS also we can understand how the query processing is efficient in the DBMS and what are the examples of it. And then in the file system, a file system requires the user to write manual procedures or programs for every new data retrieval task. So a file system requires the user to write manual procedures means or programs for every new data retrieval task. So because file system, what it contains, files, it contains files, and every file is different from other file, we know. So it can be image, it can be text file, it can be a audio file or video file. So it is totally different from one file to another file. So so it requires the user to write manual procedures or programs for every new data retrieval task. So querying means what? Retrieving data or changing data, okay, which is present in the system, and storing data and etc. So every file is different. So for every different file, here the user requires to write the manual procedures, okay, or programs for every new data retrieval task. So for all the different files, it should create different queries. The user should create different queries. So that's why the query processing is inefficient in the file system, okay. And example, if we need to find one specific record, okay, example, a student email, okay. In a massive text file, the system must scan every row from top to bottom. So this is the query. What's our query? We have to find the specific record which contains the student's email. So record means a row means, and which contains the student email. So in the massive text file, so the system must scan every row from top to bottom to find it. So so here the time consumes, it consumes time, and the query is processed inefficiently. Okay, the next example is data is often stored in different formats, so like image, audio, video, photo, etc., text, etc. Okay, and locations. Data is often stored in different formats and locations across various departments. So departments, like download is a department, and document is a department, and multiple apps are there, and other sections in our mobile phone. Okay, in various departments. So data is often stored in different formats and location across various departments. Fetching related information from these isolated islands of data requires complex, time consuming. So if we want the related information from the isolated islands, means these departments of data requires complex, time consuming. Okay, and then, so if we want to find a example is, if we want to find a resume file. Okay, resume, which is a text file, .txt file. So we have to open the app first, we have to open the file manager. Okay, and then we have to go into the mm, download section, and we have to find it. So this is called fetching. Okay, it is time consuming. Okay, and then next, here the inquiry is fetching a data. Okay, and for second example, and third example is, a file system does not have an optimizer to find the fastest way to execute a command. For example, so what optimizer does, it finds the faster way to execute a command. So for instance, if you want to join data from two different files. Okay, one from students and one from grades. Okay, it is grade. So grade, you manually write logic to open both the files and match records and handle errors. So you have to, so here the query is, we are joining data from two different files. So first is student file and another is grade file. You have to manually write logic to open both files and match records. So this particular student is having this grade, so we have to match this records and in two different files and handle errors also. And then in DBMS system, the examples are, so DBMS uses indexes, schema definitions, means structure definitions. Okay, and optimized join algorithms to retrieve data instantly. So here we are using indexes, structure definitions, and optimized join algorithms to retrieve data instantly. And examples are using a indexing mechanism, The, the DBMS jumps directly to the memory or disk address of the specific record. Okay, like example is select email from students where student ID is equals to 1001. So this command is used to jump to a memory or disk address of a specific record. So here student is a table, and so we are selecting a column, email column from a student table where student ID is a 1001. Okay, this is the query in the DBMS. Okay, so in file system what we need, we have to, from top to bottom we have to search for this email. Okay, so but just writing this email, this command, we can access it. Okay, we can access the related data. Okay, and second example is a query regarding a related data information from the isolated islands of data requires only a simple command. Okay, there is no fetching. Okay, because the relationships are already defined in the database schema. So between the tables there is already relationships are there in the database structure. Schema means structure. Okay, so that's why a command is enough to fetch the data. Okay, so in the file system we need to fetch manually. Okay, so the third, and here the example is select employee name, department name from employees. So here employees is a table name. So here these are department name and employee name are column names. Join departments on employees dot department id is equals to departments dot id semicolon. Means we are joining two tables. One is employee and one is department tables by using this query. Wherever it will be data from, if the data is present, if the student name is present in one table and the student grade is present in other table, so we can join it, those two tables we can join it. So and if the student name is one table and if the student department is in the another table, then we can join it, and whatever the data we need we can display on the screen by displaying the columns. Okay, employee name, department name are the columns from employees. Okay, so for these both tables IDs are ID column is same. And then third example is in a DBMS has a built-in query optimizer. When given a command, the optimizer evaluates hundreds of alternative execution plans, considering the most efficient joint method, examples nested loop join or high join, and executes the lowest cost plan. Okay, so in the file system we don't have optimizer to find the efficient execution plan. So optimizer, it evaluates the hundreds of alternative execution plans and considers the efficient joint, and executes the lower cost plan. And then we have a It has a less data consistency, it has more data consistency, it has a more consistency due to normalization. So data consistency means what? Information is accurate, uniform. It's accurate means up to the point, uniform, and reliable means trustable across all systems or databases. So file system, in file system it operates purely as a basic storage mechanism without built-in features to manage, okay, protect or organize data. Means there is no relation between one file to another file. Okay, there are no built-in features. Means built-in features like DML operations we have, DDL operations we have, like that. It does not have any built-in features. Okay, file system. So to manage, protect or organize data. That's why the file system provides less consistency. Obviously, if we have a relation and some update features and some other operations in the DBMS we have, so it increases the reliability, trustness, and uniform and accuracy. So that's why the DBMS has a high data consistency or more provides more consistency. Okay, and then we will see the sixth point. It has less complexity as compared to DBMS. It has more complexity. And it seventh is it provides less security as compared to DBMS, that is limited to operating system permissions. Okay, write permission, read permission we have, no? So read only permission, like that. So security is less. So in this it provides more security as compared to file system due to user role, password plus a fine grained access. Okay, so if any user want to perform any operation on the database, it requires authentication. Means their password, their username should be correct, then only it provides the interface, okay, to perform some queries or any other indexing in concurrency, etc. Okay, so in files only the operating system file or permission should be allowed to access the file. Okay, and then we have a file system is helps to store, retrieve, manipulate collection of raw data files into hard disk. Okay, stores, retrieve, manipulate and collection of raw data files into a hard disk. Okay, and DBMS helps to store, retrieve, manipulate data in database. Okay, we already know what is database, the collection of organized data. And in file system, tasks like storing, retrieving, searching, sketching or done manually, so it is difficult to manage data. And in DBMS, operations like updating, sketching, and selecting data is easier due to it allows using SQL querying. So SQL commands. So it is used easier. And then file system appropriate to handle data of small scale organizations or individual users. Okay, and this DBMS is appropriate to handle data of medium to large scale organization or multiple users. So how, why it is appropriate for a particular organizations we will see later. So the next is examples of file systems are NTFS, new technology file system, FAT 32, file allocation table 32, and XFAT, extended file allocation table, and REFS, resilient file system. For Mac operating system, APES, Apple file system, and HFS plus. And then for DBMS, examples are MariaDB, PostgreSQL, IBM DB2, Microsoft Access, etc. And next, file system stores data in a separate file in hierarchical tree. Okay, folder means the folders and file structures are like a tree. Okay, you already know the tree structure now. It will be like this. The circle represents the nodes. Okay, this is a tree. The so stores in a separate file in hierarchical, stores data in a separate file in a hierarchical tree folder. And here DBMS stores data in structured table with defined relationships. Okay, stores data in a table. Okay, and then it is used for storing unstructured data like videos, image, etc., where complex relationships aren't needed. Okay, and DBMS is used in systems where data integrity, sketching, multiple user access are critical. Means impossible or difficult. So data integrity, searching, multiple user access are critical. So in those type of systems, the DBMS is used to access these facilities. Okay, and then file system enables users to perform procedures like reading, writing, and erasure. And here DBMS enables user to perform functionalities like querying, indexing, transaction, data integrity, and concurrency, etc. So querying means we know already, retrieving or modifying anything, any data. Okay, and indexing to access a particular data. Okay, and transaction means performing some step by step operations. Okay, on on a data item. So data item example is like a bank account. So for transaction of amount between two data items means two different accounts, so that is called transactions. And data integrity and concurrency, etc. So concurrency means performing multiple transactions at a time, simultaneously. Okay, then structure. XYZT are master file directories, and these are user file directories, and these small circles are files. Okay, so and in the DBMS, end user, DBMS, and database application, we already know DBMS and database. It is a software to manipulate database, and database contains organized collection of related data, and database application which is used by user to what to send request to the DBMS. Okay, and then so what are master file directory and user file directory, UFD and MFD? What are they means? User file directory, a private folder designated for a specific user. Okay, and MFD, the top folder and directory is same. Okay, so which contains the collection of files. Okay, and MFD, the top level index for the entire computer system. When a user logs in, the MFD is searched to locate and open that user specific UFD. Okay, and then so there is no data independency, and here in DBMS there are two data independencies. Okay, logical data independency and physical data independency. So what is data independency? First we will see that data independency is the ability to modify schema definition at one level without affecting the schema definition at other level. Schema definition means structure definition. Ability to modify or change structure definition at one level without affecting the structure definition at another level. So what is logical or conceptual data independency? It is the ability to change logical level without affecting the external view or program. So here is the diagram. Here is the conceptual level, physical level, database, view 1, view 2, and view 3. So logical independency, what it says, it's the ability to change logical level, this level. Okay, this level, conceptual level. Logical level is also called conceptual level. So it is ability to change conceptual level without affecting the external views. Okay, these views. Okay, and then the example is add, modifying, deleting a new attribute or entity or relationship when possible without rewriting the existing application program. So here we are changing, what we are changing, we are adding, modifying, and deleting a new attribute. Attribute means the property of an entity. Okay, or entity or relationship is possible in a logical level. Okay, without rewriting this existing application program. And then physical data independency, ability to change physical data without changing logical data. So physical data is here, and without changing this logical data. So example is using a new storage device like hard disk or magnetic tape. So it does not affect the this logical level, because only we are changing the storage type. Okay, and then here, why the file systems does not have data independency, because data independency means what? Modifying the schema definitions at one level without affecting the schema definition at other level. So the file system, it has no abstraction layer, means hidden layer means logical layer. Okay, separating physical storage from the application. This is the physical level from the application. These are the applications. So it does not have conceptual level. So that's why it does not have the data independency. So there is no levels to be compared. Okay, means uh, there is no there is there is no sufficient number of layers to be compared while in terms of logical data independency. Okay, to compare the affecting, to observe the comparing effect. Okay, so we don't have sufficient number of levels. That's why the that's why the file system does not have data independency. And then we have uh, difficult to share the data and easy to share the data. Okay, in the DBMS it is easy to share, and in the file system it is difficult to share data. Why means, so we will understand by using examples. So in the file system, data is spread across isolated files. So sharing data between different departments. Assume that if CSC is a department and AAA is a department, sharing the data means sharing the file between two departments usually means making redundant copies of the same file. It makes the redundant copies. So that's why it is difficult to share the data. And no concurrent access control. If two users or try to edit the same file simultaneously, okay, two persons are doing editing the same file simultaneously at a time, so it can leads to data corruption or lost updates. What is data corruption? What is data corruption means, data becomes unreadable, incomplete, or altered by accident. So data lost update means occurs when the two users edit the same data at the same time and one person's changes overwrite and erase the other person's changes. So that is called lost the updates. Okay. The first person updates are lost by the action of second person. So here we have an example so we can understand properly. So I open a shared spreadsheet to update customer record. Okay, open a spreadsheet to update the customer records. So while saving, the network drops. Okay, the file breaks, and the next time anyone tries to open it, they get an error saying that the file is corrupted and can't be opened. and the file original structure is damaged. Okay. And in the DBMS, like using a platform like MySQL, both the sales and billing teams query the same centralized customer table, okay, at a time simultaneously. Okay, the sales and billing teams, the two different teams are querying the same centralized customer table. If a customer updates, means the sales and billing teams are having the centralized table, same centralized table, okay, in the database, stored in the database. So if customer updates their phone number, the change is instantly visible across all departments without any duplicate entries. So it means if the customer table is queried by the sales team, then the updated phone number will be displayed in the to the on the screen to the sales team. And if the billing team is queried about the customer table, the updated phone number is also visible to them also. Okay, so that's the meaning that the change is instantly visible across all departments without any duplicate entries. So so while in the file system, the example would be the sales department stores customer phone numbers in a sales.txt file, and while the billing department stores them in a billing.txt file. So, if a customer updates their phone number, it must be manually updated in both files. Otherwise, the 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 data become inconsistent. Inconsistent means consistent means accurate information and reliable, and it becomes untrusted. Okay, and accuracy will be gone. So here we need a manual updatation in both files. So here we are storing in a centralized system which is database, so we don't need to update twice. Okay, and then here the manual updatation is required and the repetition also occurs. So so the sharing of data is difficult here in the file system. Okay, and the second example of DBMS data sharing is multiple users can view or update distinct records simultaneously without interfering with one another, called concurrence management. Okay, so multiple users can retrieve, okay, or update or can view uh, simultaneously tables or records, anything, okay, from the database. So in the file system we don't have concurrent control, so it occurs in data corruption and lost updates. Okay, if anything, if if anything, internet fails, uh, we have seen in the example, if internet fails, then the file is breaks and the other cannot be accessed. Okay, so there is no concurrent control in the file system. Okay, and then the data become unreadable, okay, by the other systems. So in this, simultaneous access will be there for multiple users, okay. And then the third is, all data is housed in one central database, ensuring that any authorized user or application access the same single source, okay. Here we are using same single source, multiple users are using same single source. And the in the file system, multiple users are using same system, but there is no concurrent control, okay, in the file system. And then we will see the 19th point, does not allow data abstraction. It follows the data abstraction, okay. So what is data abstraction? Means, if abstraction means what? Hiding. So if we open a file, example, if we open a file, the data is visible on, the data is not abstracted anywhere, okay. In the DBMS, if we query something, means if we update a table, okay, or if we access, or we have to access a particular column, okay, only a column. So we can use command and we can access it, only that particular column. The whole data is hidden, okay. The whole database is hidden, okay. And the integrity constraints are difficult to implement, and here the in DBMS, integrity constraints are easy to implement. So what are integrity constraints? Integrity constraints, these are the set of automated rules in a database to ensure that the data remains accurate, consistent and reliable. So they act as a safeguards to block invalid information from being added or modified, or ensuring data quality across the entire system, means database system, okay. These are the set of automated rules to the in a database to ensure the data remains accurate, consistent and reliable. So what are they? These are some types of constraints: domain constraint, entity constraint, referential constraint, no null constraint and check constraint. So domain constraint means defines the type of the domain. Means in a table there is a column. Columns are there. So domain indicates the column. Column means type of the column, okay. Whether it is a integer, whether it stores the integer values, or whether it stores the uh, what uh, characters, means we use varchar, and some other domains will be there. So it indicates that, okay. Entity constraints must be unique row using primary key, okay. Each row must be unique. And referential constraints maintain logical relationship, okay. So between two tables it will maintain the logical relationship. Means in one table we will use primary key, and in other table we will use foreign key. So these two tables are related to each other. So this primary key and logical key contain same values in the two tables. So they are logically related. Okay. No null constraint. Specific column can't be emptied when a new entry is created. Okay. And check constraint. Entered data meets a custom logical condition. Okay. It will be like uh, if department number, if this for example employee table is there, if employee name is there, in that employee name is there and employee salary will be there, two columns are there. So uh, custom logical condition means we are creating this table by taking a condition like if department number greater than or equals to 25,000. Then using that condition we have created that. Then we have inserted a row in this table which contains employee name as XYZ, and salary is maybe 26,000. So it does not insert the row because it does not satisfy the condition. Okay, if if I give uh, 24,000, then it will accept the query and give the output, and the table contains one extra row that is I have added now, that is XY name and 25,000 salary. Okay, that's the meaning of check constraint. And then in the file system, so uh, why it is difficult to develop, so why it is difficult to implement so in the file system, why it is difficult to implement integrity constraints, and why in the DBMS it is easy to implement the integrity constraints, we will see now. So in the file system, developers must write custom repetitive validation code for every application accessing the data. Okay, so developers must write custom repetitive validation, means repeatedly they are writing own code, valid own code for every application accessing the data or file, because each file is different from other file. Okay, it does not have any relationship between them. Okay, and in DBMS it provides built-in declarative rules that the database engine automatically enforces. Okay, these are the rules. Okay, which are not present in file system but they are in DBMS. Okay, so that's why. And if we consider the example in DBMS, to ensure an order can't exist without a valid customer, we declare a for region key. So order can't exist without a valid customer, we declare a for region key. For region key bracket of customer ID, reference customers ID. Okay, and file system. So we are declaring a for region key for a valid customer, their order for existing the order of the valid customer, like this. And in the file system, to implement this in a file system, example matching IDs across two .txt or .csv files, the developer must manually write code to scan and cross reference both files before saving any new data. Okay, so here in the DBMS, consider two tables. Okay, so two tables, one has a primary key and second has a foreign key. These foreign key columns are has a two has same values in both tables. Okay, so and for region key property is only the values which are present in first table primary key column is accepted by the for region key column in the second table. So we are providing, we are making exist the order for a valid customer. Okay, if id is different, the foreign key column does not accept it. Okay, and in this file system, to implement this in a file system, matching IDs across two .txt files. Okay, the developer must manually write code to scan and cross reference both files before saving any new data. He has to write a program to scan and cross reference, okay, both files. Okay, uh, to check if the ID which which he or she is entering is present already, is matching with the first file or not. Okay, severely impacting application and code complexity. So here, yes, developer has to check if one file is file 1 and one another file is file 2. So if we want to enter the data in the file 2, okay, so in the customer ID, okay, here also customer ID is there. So we are checking the customer id values in the first file, and we have to enter it here in the second file. And there should not be mismatch of IDs. If it is mismatch, means there is not a valid customer. Okay, and the order can't exist for that customer. So we should not add the a different value for the customer id which is not present in the file 1 customer id column. Okay, so like this, he has to write the code and and then scan, then cross reference both files. Okay, so it is a time taking process. So in this we are only considering in the table 1 primary key, and considering for origin key in the second table. So if the for-origin key is uh, entered a new value, means different value other than this primary key column in the first table, then it will not accept. Okay, okay. And only the if the value which we are entering is in the for-origin key column, if it is matched with the primary key, then only it entered in this column. So all the management is taken by the system only. Here we have to manually check it. So that's why integrity constraints are difficult to implement in the file system and easy to implement in the database management system. Hope you have understand today's class, and if you have any doubt, ask me in the comment section. And if you feel this video is helpful, then like, subscribe, share and comment it. Thank you, bye. I will see you in the next class. Thank you, bye.